everybody, and welcome to the Cisco Support Community Expert Series webcast. Today we are going to talk about Layer3 Multicast. This session will focus on security and best practices. My name is Hilda Arteaga, and I'm a community manager of the Cisco Support Community and a moderator of today's event. The Cisco Support Community is an online forum where over 500,000 members when you get an answer to your technical questions prior to opening cases with the tag. Also, you can answer many questions or contribute, so as read documents, videos, and blogs. We invite you to know more about the community. Well, before we start, I would like to share with you some news and some upcoming events that you can check out here at the Cisco Support Community. But first of all, for all of you who have additional questions, we will have an Ask the Expert forum open till Friday, December 8th. Luis Espejel and Miguel Perez, they will be helping us to answer all the questions related to Multicast, Layer3, Multicast implementation, API, Multicast, and all the things that you need to have your network and set all the information properly, okay? All the information about these events, I'm going to paste them out in the chat so you can have access to all of them and you can review and make your questions. Also, I would like to invite you to this special event. It's talking about security. So today, security is very important on the companies and enterprises. So you want to learn everything about Cisco AnyConnect. We will have Adita and Punesh answering all the questions till December 8th. These experts are very good, so I really recommend you and highly recommend you to visit this event and clarify all your questions regarding this Cisco AnyConnect, so you can connect all your employees and all your teammates all around the globe. This event is open only to Cisco customers and partners, but you are welcome to open all your queries. And also, I would like to invite you, in case there is someone here who can speak Portuguese, there's going to be an upcoming webcast about hyperconvergence with Cisco HyperFlex. This will have place on December 13th at 14 hours of Brasilia. The presenter will be Pedro Ivo Santos, and you are more than welcome to register in case you speak this language. As well, I would like to invite you to an Ask the Expert event. This will be related to all the new Java release, 11x, and all the best troubleshooting practices. The presenter is Ricardo Rendon, and he will solve all the queries regarding this technology till December 15th. This event is in Spanish, so if any of you speak Spanish, then you are more than welcome to clarify your queries here. Also, I would like to invite you to become an event top contributor. We invite you to participate here in the community. All the participations that you do, everything that you post here, all the documents, all the queries that you solve here, they can make you become a top contributor. So in that way, people can know you more all around the world, all your technical peers, and everyone here can find more about you. I invite you to know the VIP class from this year so you can learn more about it. Also, I would like to invite you to rate all the content that there is on the community. The reason why is just please help us to recognize all the quantity content in the community. Sometimes we get an answer, sometimes we solve a question, but no one really gives us a vote. So we have an option to give a helpful vote, so that can let people know that what they are doing is okay, or we can also accept a solution. So every time you find something that really solves your question, or a document that really helps you out for something, please help us to give a helpful vote or accept it as a solution. It encourages participation and it helps us to have better quality content in the community. Well, for today, this presentation, there's just one announcement that I really would like to do. Today we have Luis Espejel and David Ramirez. Unfortunately, due to particular reasons and personal reasons, David is not going to be able to join us for today, but we will have Luis Espejel as an expert, and he was going to help us out to deliver all this presentation. So what I would like to do is present this expert for you guys. So Luis is a telecommunications manager of Yenova. This is an oil and gas company. He currently works with Cisco iOS and Cisco iOS XS platform, and NX to some extent. He has also worked before as a senior engineer with the routing protocols team in Cisco Global Tech. He has worked as well as a network telecommunications manager for Cisco General Motors, and as well as an engineer in Axtel, a major internet service provider company. Luis holds an electronics and communications degree and a postgraduate degree in marketing and one in telecommunications. He has several certifications such as Google Power Search, IT Foundation, Certified Ethical Hacker, CCNA in Data Center, Cybersecurity Specialist, and a CCIA in Routing and Switching. Welcome, Luis, and thank you very much for being here. I know you're going to miss David, but we really appreciate that you are here to join us for this event. Welcome, and thank you very much.
Thanks for the opportunity, Hilda.
No, it's a pleasure. And well, besides the fact that David is not here, I just would like to mention that he's a network engineer at AstraZeneca Pharmaceutica, and he works in a one implementation project and land refresh and migration. All right, he's not right here, but he helped out to build up all this content, and we really appreciate that he's here in all the content. Okay, also would like to present you today's question manager, Miguel Perez. He's going to help us out to solve all your technical questions and everything related to this session. Miguel is a customer support engineer at the Cisco Technical Support Center at the Routing Protocols team. He has been collaborating in the past 3 years. Before, he has worked in Tronex, which is a Cisco partner, and in AT&T as a support engineer. Miguel holds a bachelor's degree in electronics and communication engineer, and he holds several certifications such as CCNA, CCNPA, CCDA, and CCDPE. Welcome, Miguel, and thank you very much for joining us today.
Hi, everyone.
Okay, well, for all of you who have interest in this session and you would like to check out this presentation deeply, you can find it out at the community. We will post the link where you can download it and check out this presentation and all the slides at the Cisco support community. This will be available on the chat, so please feel free to check it out and have it for further reference. Also, we'd like to invite you to submit all your questions and all the doubts that you have. I know in this session you have two options. You have the Q&A, which is at the top right corner, and you have also the chat option. We really encourage you to please use the Q&A panel to submit all your questions related to this session. The reason why is because for us it's so much easier to check out all the queries and answer to all of them. In other hand, if you have questions related to audio, you have issues looking at the screen, if you like to make an inquiry just that is not 100% related to this session, you just please use the chat and we will help you out with everything you have. Well, from now on, the only thing I have to do is just thank all of you for being here. I know this is going to be a great session, and I hope you learn a lot from this, from Luis and from Miguel. So thank you very much. And Luis, I'm going to pass you the mic so you can start the presentation. Please go ahead, Luis.
Hello, everyone. Thank you for attending. Well, today we are going to see some Layer 3 multicast security mechanisms that we have. And well, as Hilda mentioned, unfortunately, David won't be here, so this presentation is split in two parts. The first is the security, and the second one is the best practices. I will be explaining both. Please feel free to ask any questions that you might have in the Q&A section, okay? Little question here. Do you use multicast in your network? Well, what is multicast? What is the problem that it solves? Well, as network engineers, we all know that there are some applications or data applications that we need to collect or distribute along the network. But if we use the traditional broadcast solutions, it won't be efficient, right? Because we will be flooding the traffic to all the network, making the bandwidth scarce. So we need a better mechanism to distribute such kind of traffic. One of the examples that we see here is, for example, when we have a video broadcast. I think that we have all experienced video broadcast in the companies where we work, where somebody is, for example, in broadcasting a message, but not everyone is interested in listening to that message or watching the video, right? So only those that are connected to the applications are interested in to receive that broadcast. So how to do that in an efficient way? Well, using multicast. Multicast is a mechanism, or well, a technology that allows to deliver the interesting traffic only for those receivers who have expressed the interest to receive it, right? And we have a lot of applications like one-to-many applications like TV, radio, distance learning. This is an example, this WebEx. Application updates, data distribution like the weather, news, NTP, IoT sensors. Okay, or we can have many-to-many applications like audio and video communication, data distribution and synchronization, group chat, financial, polling, multiplayer games. In this case, financial is a very good example because in the data centers where the financial applications are running, they distribute the states for the transactions that are made using multicast. And usually it's a bidirectional multicast, but it's a good application on how the many-to-many multicast works. And this is different, like sharing with everyone, because when I say many-to-many, it's one source could be sharing its own traffic while the source is sending the traffic to the interest parties, but at the same time, maybe the one of the parties that is receiving is also sharing with the other source, but not necessarily they all belong to the groups receiving all the traffic, right? So, well, that's why we need the many to many and many to one, like data collection, video surveillance, polling, IoT sensors. Here, a good example is the video surveillance. I'm sorry, because when we have a big amount of cameras in the network, all the cameras are sending the video stream using a multicast group, right? So then we have a receiver which is subscribed to that group and receives all the traffic from the cameras in a better way than having communication from IP to IP. That's a better way to handle that communication. Okay, now multicast is based, well, at least in the layer 3, multicast is based in the protocol independent multicast protocol, which is signaling that we use in the network to discover the paths that we will use for the multicast streams. This is important because this is a routing protocol, but multicast is an overlay that runs over a network, meaning that we have built a network using routing protocols like OSPF, EIGRP, BGP, maybe static routes, any solution that you want, right? And you will route usually traffic from the source to the destinations. In the case of multicast, this is an overlay, meaning a solution that is placed on the top of that routing solution, and then it will distribute the traffic, but usually in an inverse fashion, meaning like instead of going from source to destination, we will build a shared tree that usually goes from the destination to the source, okay? But always relying in the routing information that we have below, I'm sorry. Now, that means that we need a very solid and well-planned routing infrastructure in order to multicast to work, right? And PIM works with these packets. One of these is the hello packet, which is used for discovering the neighbors and maintaining adjacencies and signaling, important stuff between the peers. The other packets, I have divided the packets in unicast and multicast because they are being sent in a different way. When I say multicast, they are sent using the 224.0.0.13 address. It's like any routing protocol. It's a link local packet that will reach only a directly connected network. Okay, and we have signaling, as I mentioned, like join prune. This is used to indicate to the RP when we have a receiver that wants to join a group, or the DF select for PIM VDIR, which one discussed today. Okay, the PIM assert, which will decide which is the best way to take for a flow of multicast. When we have several paths in a network that share the same metric in the routing protocol, in order to have a very good use of the bandwidth, we will use only one of the paths, not two, because that will be duplicate the traffic, right? So how we do decide what is the best path? Using PIM assert and PIM Bootstrap, which is a way, a standardized way to distribute the information for an RP in the network. Now we have another unicast packets that are used for PIM, which we have here, like source register. That's when the first hop router receives a multicast stream, the first packet that we get, it's sent to the RP, and it's a register, and it will start within a state. Okay, I will describe the states in the next slide. A register stop, which means that we don't want to forward that traffic, and the BSR candidate, which is the advertising for the RP in the network. This is using all PIM. Okay. Now, how does this work? When we have a receiver, here you can see debug outputs. Okay, the first one it's from the switch, from the layer 2 switch. We have a receiver that is interested in receiving a multicast stream. Okay, so what is happening here? Well, using IGMP version 2, the receiver is sharing with the switch its interest to receive that. So the switch will create an IGMP entry saying that he has a receiver interested in that group, right? So you can see here that it will send in the last line the report to the router, right? The router is the last hop router because it's the last one in the stream from source to receiver. Okay, this is a very simple topology, but it will explain very well how the logic works. So this layer 2 will share that state with the last hop router, which will translate the IGMP into a PIM message, okay, and it will create an star comma G entry. You can see in the second box we have an star comma 239.1.2.3. That's an state, and that's an indication that we have a receiver. Okay. Now the next step is sharing that with the RP. The RP will receive that information saying, okay, I have a receiver that wants to receive the multicast flow for the 239.1.2.3, okay, and it will change the states. You can see here that it's setting some flags in order to the group to work, okay, and it will check, do I am the RP for that group? Okay, yes, I am. It's the encapsulating the register, okay, because we at the same time are receiving from the source, from the first hop router, an encapsulated packet saying that we have a source for that group that we have already received. So in the last line from the RP, you can see that we have a NES, G entry, right? So here you can see that we have a source which is 10.5.6.6 for the group 239.1.2.3, and here in the RP we have then the complete communication, let's say, okay, because we have a receiver that we know in the RP and a source that we know in the RP. So the next step is we will share that information between the last hop router and the first hop router, and they will move to the shared tree. The shared tree is the path that will be built over the routing information that we have, because at first the traffic will flow through the RP, but then the RP will send a signaling indicating that they should use the most optimal path in the network, and that path will be going from the first hop router to the PIM router to the last hop router, and then the receiver over the layer 2 switch, right? So in the first hop router, we can also see those states. We see that we have received the first packet from the source, which is 10.5.6.6, okay, and it's for the group that we have already mentioned, okay, and it will be sending a packet for the RP. The RP in this case have responded with the join prune, okay, and you can see in the third line that it has set the S bit, which is sparse. It will be using the best path, okay. And well, we have the whole signaling for that to work. Now going to the next one, I mentioned a lot the RP, and well, here the RP it's like it's a reference in the network. which all the routers will share the states, and then it will control if that group has a receiver. Well, we need to forward that traffic, or maybe we need to stop that traffic in one particular section of the network if nobody is interested anymore, or well, all the signaling for the traffic flowing in the network is done by the RP. Okay. Now we can select the RP in different ways. We can have an static RP or several static RPs, because we can define the RP for a particular group or set of groups of multicast in the network. So, well, there are several ways to do that with a static RP. Okay, now we have another mechanism that is Cisco proprietary, that is auto RP, which is a dynamic RP propagation using announce and discovery messages. The announce messages are sent to the 224.0.1.39, and those messages are sent from the devices that are willing to become an RP. Okay. Now they have to communicate with an RP that it will distribute that information in the network using discovery messages. Okay. Sometimes it's kind of confused, the way they are doing this because of the names in the rows. I mean, sometimes there are, well, from experience, I know people who are, it's confused from the discovery messages, thinking that the discover message will discover another RP, but it's not that way. The RP will send to the auto RP information the announce message. The announce message will receive that message and then distribute to all the PIM routers the states for the RPs using the discovery messages. Okay. Now in the BSR, it's a Bootstrap protocol. Well, we have a dynamic RP, but in this case using ping messages, because as I explained before, these messages are sent in a link local fashion. They are going to the 224.0.0.13. They work differently, because if you can see in the auto RP, that's not a local scope multicast packet. That means that those packets are reaching several routers, okay, when we have that distribution over the network. But in the case of the BSR, well, it will reach only the directly connected routers. But it's because of that also that is sometimes harder to control, okay? Because, we need those packets not only for the BSR, but for the PIM states control. So we cannot just block it for security. That's a consideration that we have to keep in mind. Now, we have also Anycast. That's another method to have RPs in the network, where we can assign in several points of the network, especially if the network is large, let's say, we can have several routers acting as RP, but we can declare only one RP, I mean one IP address, and then we will have, for example, a loopback with the same IP address in several devices along the network. Okay. Now, they need to share states between them. And the way that they do that is using MSDP, Multicast Source Discovery Protocol. Because if we declare a couple of loopbacks with the same IP address, the routing protocols will send the traffic to the shortest path, let's say, to the first device that we have. And then this device needs to share the states that he has learned, or it has learned, over the network with the other device. And that exchange of information is using MSDP. There are another solutions like Phantom RP or, other implementations, especially when we are using more elaborated multicast solutions like PIMVD, but they are not in the scope of this webcast. Okay, but there's plenty of information of all the RP engineering in the Cisco site. Here you can see a debug for the RP with the auto RP, distribution. Okay, here in this example, I use the output from the last hop router, okay, where you can see that I uh, receive a packet for the group, the 239.1.3, okay. I have an RP that it's the 10.0.0.4, okay, but this packet is being sent from the 1.1.1.1. I use this to illustrate the way that the AutoRP works. As I mentioned before, well, there's an announce packet that is sent to the RP. In this case, the announce packet was sent by the 10.0.0.4 for the RP that it is distributing the states or the auto RP information, which is the 1.1.1.1. Okay, so there are two devices, one which is the actual RP for the group, and the other that is the RP distributing the RP information. In this case, the last hop router is receiving that state from the auto RP and discovery. So when we see in the auto RP, I'm sorry, in the RP, the auto RP states, we can see here that we are announcing, okay, the 10.0.0.4 as the RP for the group 239.1.2.3, which is the packet that we saw before. Now, we also see that we have received the packet from the 10.0.0.4 into the 1.1.1. And this is because there are two entities. In this case, this example was taken from only one device using two loopbacks, but even then the communication occurs, okay? The device wanting to be an RP for a group is announcing the group, okay, and itself as an RP, and then the RP receiving that is sending the discovery. If you have questions regarding this, please let us know in the Q&A section. Now, because of all the mechanisms that I have explained, we have several vectors of attack, right? So how can a multicast network being attacked? Well, we have possible attacks from the auto RP or BSR messages. We could have fake PIM hellos, okay, to change the DR, which is the role in which, well, in the case of multicast, I forgot to mention that. In the case of multicast, when we have two PIM routers in the same LAN, let's say, or the same IP segment, we will use one only to forward traffic, and that's the DR, the designated router. That decision is taken by exchanging ping hellos. So we can fake some ping hellos in order to change that and cause problems in the network. There are several ways in how this could affect the network. Now, we have also PIM joins that we could fake, meaning like not really a host that is interested in some multicast traffic, requesting that traffic and then flooding the network with unnecessary traffic or packets, okay, causing traffic in the network or issues to the network devices. So those are possible attacks from hosts. So the recommendation here is a host should never run PIM, okay? That should be done only by network devices. Now, we can have some considerations here in order to reduce those attack surface, like passive interfaces. I mean, we can enable the PIM in one interface and then declare that that interface should be passive, meaning that we won't exchange states with another device connected there, because if we already know that there are only hosts, there's no any reason why we want to have an exchange of PIM states with a device there, right? We have a control plane policing, which is also a nice way to protect the control plane, because also we have seen some situations in which, for example, there are literally hundreds of devices sending joins or registers to an RP, and then overwhelm the RP CPU, making it crash. Okay, so that's also a good consideration to have here. Control plane policing. We can use a plain access list in order to filter multicast traffic in the network boundaries. That's only a simple access list that could protect us from unwanted attacks, right? Well, or unwanted multicast traffic or PIM control traffic. Now, we have also to consider to have a very good routing design, set boundaries, stop devices, passive interfaces, redundancies, plan accordingly to the intended way to work in the network. And this is very important because, well, most of cases that we have seen in which traffic flows over an unwanted path, it's because the underlying routing solution is not well planned. So we need to plan very well which is the routing path that we will use. Okay. Now we have also another considerations that we can have here, like IPPMRP address override. When we use static RP, we can consider like having an static RP with override in order to avoid that any other kind of information that we receive, like auto RP or VSR, it's changing that RP information that we are using. We can use also auto RP control or inbound access list to filter the IGMP queries or PIN messages. Okay. How we can control the PIM neighbors? Well, we have a feature here where that we can use with the neighbor filter. You can see here that I have enabled, well, I have configured first an access list, then permit the neighbor's address, and then use under the interface a neighbor filter. In that way, we can filter which sources for the multicast PIM control traffic we are receiving. And that's because, as I said, that's link local. And if you think that we are connected over a LAN, maybe one host is trying to attack us and sending PIM hellos, right? In this way, we will take on count only or process only the authorized neighbors, and the adjacency will be formed only between those included in the access list. We can have also that for the, or well, a similar solution for MSDP, where we can set a password in order to avoid that anyone unauthorized is establishing an MSDP relation with our RP. For the auto RP control, here you can see the example configuration. In this case, well, we have an access list permitting the RPs that we want to use, and then the groups that we want to permit. Okay. In this case, I also set an access list that is number 3, denying the auto RP groups. Those IP addresses are the ones used to distribute auto RP states. Okay. So then you can see that I have configured IPPMRP announce filter, which means that I'm only taking in the RP, processing only the RP information for those RPs included in my access list 1. And I will do that only for the groups that are included in the group list 2. In this case, that group list includes all the multicast space, right? But we can split that into several segments, because maybe you are interested in receiving only, I don't know, 239 or 240 or any space that you define, right? Like your interesting traffic. So in that way, we will avoid or prevent that anyone is injecting our auto RP information into the RP using auto RP announcements. Now, you can see in the second, the second block, that I'm configuring the interface. Okay, and in the interface, I'm setting multicast boundaries. So in the multicast boundary, when I say multicast boundary 3, what I'm saying is that I don't want to distribute the packets for the auto RP, which are the 224.0.1.39 and 40, out of that interface. Okay. I'm also in the second line filtering the auto RP information, which is another way to do the same that I was doing in the first one, or the boundary out. Okay, this boundary out is very interesting because, as I said before, you can have a host that is faking a join, and let's say that you have a server, and I don't know, somebody in the LAN server is faking a join, and maybe because of that, you might cause issues in the segment for your servers, right? So in order to prevent that anyone is requesting multicast traffic in that segment, you can set the multicast boundary out in that interface. Let's say, I don't know, a VLAN interface or a routed port interface, so that that port won't be included into the outgoing list, meaning that there's no way that the router will forward multicast traffic over that interface. Okay, that's a very good measure to protect that segment. And we have also the boundary in, which will prevent that if somebody is faking multicast traffic, okay, you won't take that multicast traffic and you cannot create an S, G entry there, and then the traffic won't pass that interface. I mean, they can inject the traffic will be received in that interface, but the interface won't forward that traffic. Okay, and then you can see an example there for what I explained for the PIM-RP announce filter. You can see here in the last section that we have received an announcement, okay, and we filter that. And in the second and third line in that block, you can see filtered for that group, meaning that I received that information, but because it's excluded from my configuration, it's not an untrust device. Well, that device won't be considered by the RP. Okay, so you can see that in action. Now we can have a BSR control also, but the problem with BSR is that it doesn't include the same controls as auto RP. There are some people who prefer to use BSR than auto RP. Auto RP is previous; it's older than BSR, but includes more granular control than BSR. So in this way, well, in this case, I would say that well, it depends on your preference on how would you like to filter or protect your control plane for auto RP or BSR. In this case, you can set a PIM BSR border, which it will exclude the information received on that interface from becoming an RP. But the problem is that when we are doing that, we are doing it for all the groups. Okay, there's no granular implementation like in the auto RP that we saw that we can define which are the groups that we want to include or to exclude. In this way, no, it will block all the BSR messages. So it's only like setting a boundary, and well, that's it. We have also another mechanism that is the multicast access control. Well, in this case, there are several ways that we can protect the network. For example, we can define IP IGMP access groups, which will set which are the valid groups that we want to receive in that interface. That's for the layer 2 infrastructure. Okay, so when a receiver sends an IGMP message saying, hey, I want to receive this group, you will validate against the access group or the access list that you have defined and say, oh, this is a valid group or this is not a valid group. If it is not a valid group, it won't be processed. Okay, it will be discarded. Now we have also another way. This is in layer 2. We can use also IP multicast group range, which will make a similar function, but this is in layer 3. Okay, because in this case it will affect the PIM state creation. We can define also a list, and that list will include all the groups that we want or that we don't want to receive. Okay, and then we apply that globally in a router, and in that way we will have another other way to filter the packets that we don't want. Okay, now we have control plane scoping. Okay, where we can have the IP multicast boundary. As we saw in the previous examples, we can set those boundaries in order to avoid or to prevent to receive fake messages or unwanted messages. Sometimes I would say that it's not because they are attacks, but misconfigurations from partners or another implementations, right? We have also packet level filtering. Okay, we can have access groups. We have also IPPIM accept registries. okay, which we can define in order to accept traffic only from authorized sources. And we have mroutes limit, which we are used to define what are the amount of routes that we want to install in a device. And, let's say that I don't know, maybe you have 10 groups that you will use in your network. So you define that route limit for 20 maybe, because you will have the start Gs and the S Gs installed. So maybe you will need only 20 routes. You define that route limit, and then all the routers will install only 20 M routes, okay? Or you can define that for interfaces if you want to define how many interfaces you will receive over the interface, okay? Well, so far this is the this is the presentation for the multicast security, and we will go for the reference, which are included here in the presentation, and then we will go over the best practices. Please feel free to ask any questions that you will have in the Q&A. Okay, Miguel will help us to answer those questions. We will have another polling question here. What is the device that we use to distribute the multicast routes to devices in the network? For the best practices, the best practices, in this case, this presentation is a collection of the recommendations that we have in order to implement multicast, but they can apply to many other solutions, not only multicast, okay? And I will go quickly over those recommendations because we have a lab session at the end, okay? But one of the recommendations is we should use point-to-point links in the core. And this is because when we have layer 2 links between core switches, sometimes we have unneeded complexity, okay? So, well, the way that we consider how to design that core, it's important because, well, when we have the complexity for the layer 2, sometimes we need, for example, a spanning tree, and every time that the spanning tree changes, well, we will receive a topology change. The ports are set into the learning or stop state, depending on what spanning tree protocol you are running, okay? And that will affect the PIM, well, not the PIM, the multicast traffic flowing over the network. This will affect also all the routing protocols. That's something that you need to consider. Every time that topology change occur, okay, sometimes the hello messages for EIRP, BGP, or whatever protocol that you're running are affected, okay, because of that, and then we have a problem in the layer 3 only. I'm sorry, also, and not only in the layer 2. So that will change not only the layer 2 topology, but also the topology for the layer 3. And then once that the layer 3 has established again, we have to establish again PIM, which will affect the traffic for all the multicast flows, right? So that's why it's important to have a very good, solid layer 2 design, okay? Now, we will discuss PIM assert. As I was mentioned before, when we have several paths that are layer 3 paths, not layer 2, okay, we will decide which is the one that it will be forwarding the traffic. In this case, we have, let's assume that we have only one routing protocol running here, and they both paths from the source to the receiver, I mean the path over the left or the path over the right, are having the same metric. If that's the case, well, if that's the case, we will decide over the higher IP address from the source perspective in order to forward the traffic. That's the PIM assert mechanism. So PIM will decide to forward the traffic over the left or the right according to the metric in the routing protocol, but if the metric is the same, according to the higher IP address. That will be the on-time mechanism, okay? That's the PIM assert mechanism. Okay, and well, this is the explanation for PIM assert. I'm sorry to rush this, but well, we need to have the laugh at the end. Okay, now we need also to have a very good tuning for the loop-free layer 2. Okay, as I was mentioning, we could have spanning tree or rapid spanning tree. Okay, uh, and well, the topology changes will affect the routing protocols, as I was explaining. Okay, so the recommendation is when you need to use the spanning tree, use rapid per VLAN spanning tree plus, and this is because you can use port fast and all the other mechanisms in order to reduce the impact of any topology change, right? That's why we recommend do that. Also, well, you need to hard code the interfaces, meaning like if they are going to be used for access, well, define them as access. If they are going to be used as trunks, well, define them as trunks and everything. That will reduce the information. I'm sorry, the impact for any topology change. Okay, and also if you are using BTP, well, you need to define also a good policy over that, right? Um, you can also define a traffic storm control. Okay, well, this is because when we have a topology change and those ports that are protected that go up again, that the switch won't have all the MAC addresses information or the IGMP states in order to select which are the ports that should receive the traffic. So the problem is when we have a topology change in a non very well designed network, once that the convergence is reached, the switch will flood the multicast traffic to all the interfaces because that's the way that they are designed in order to protect the interesting traffic. Okay, this is the same, and well, the configurations that are recommended, we can define for the interface, storm control, broadcast, and the levels. Well, the multicast solution is an overlay over the routing infrastructure, right? So we have here some recommendations that we need to set for the IGPs, like well, we can reduce the hello timers in order to force for a fastest convergence over the IGPs. Okay, here the recommendation is to set the hellos, but it's not always possible because also when you set very fast hello packets, that could impact the CPU. So this is one approach, and the other approach is to use BFD. Also, for OSPF, you can change the metrics for the LSA calculation throttle. That's another way to optimize OSPF. And well, here you can see an example of how to force that calculation to a faster pace. As it's mentioned here, if you change the timers for one device, well, it should be done for all the devices. Okay. Now for IGMP snooping, well, all the layer 2 switches for Cisco support IGMP snooping. Okay, but we should define all the groups that we want to receive and which are the ones that we don't want, right? In order to avoid unnecessary states. We can define also a Snoopy query. Okay, uh, this query will respond to the membership reports. Okay, and well, it's a mechanism over the layer 2 in order to share those IGMP states with the PIM interfaces that will share that over the network. Because let's remember that IGMP is layer 2 and PIM is layer 3. Okay. Also, the recommendation is never use multicast groups that are 0.0 or 128.0 in the second and third octets, right? We should never use also 239./8, okay, for internal applications. There are several RFCs defining the multicast addresses that we can use for the groups, which we should follow. Okay, I didn't mention that, but the 224.0.0/24s are only link local multicast messages. That means that it won't go beyond the directly connected device. Okay, but for all the others, there are very well defined groups that we can use depending on the application that we want. We should use the 223 GLOB addresses for interdomain applications, PIM specific source multicast, okay? And well, if we need to use external addresses, we can request for the IANA for the 224s, okay? Those are public IP addresses for the multicast groups. We have the PIM query interval tuning, okay? That's also a way that we can optimize the PIM protocol because, well, PIM is sent every 30 seconds, right? And because of that, sometimes there occur some situations where the DR could fail, let's say, and then in order to detect that failure, it will take over 1 minute and a half to have a change. Okay, so if the application is critical, let's say, we can reduce those timers in order to make it faster. So that's another consideration that you can have in the best practices recommendations. Here is the description how to do it. Well, the recommendation is a query interval of 1 second, but never less than 500 milliseconds. Okay. Also, remember, every time that we change a hello interval, this will affect the CPU. Also, we can change the register rate limits. Okay, that's because what's happening with we have several sources sending traffic at the same time. Well, the RP will receive all the register packets uh, all at the same time, and then it could be overwhelmed. And that could cause a reload or a crash or any other issue. So in order to prevent that, what we can do is to reduce the rate limit. With that instruction, that is IP PIM register rate limit rate, we will set a threshold in order to receive, I don't know, maybe 100 registers a second or at a time, okay? In that way, we will reduce the overwhelming of the CPU. Now, we have a static RP and auto RP listener. We can use the static RP or we can use the auto RP listener depending on the way that we want to use, okay? As I explained before, well, they are different mechanisms to advertise or to define an RP in the network. You can see when we decide to use the static RP, in this case, the RP address is defined as 1.1.1 for an access list 1, okay, which will permit that this RP will work only for this group. Okay, is there a way also to do that with the auto RP, which I mentioned before? So remember, it's always important to define which are the groups that we want to use in the network. The recommendation is never to let them be open. In the auto RP listener, well, you define the auto RP listener, and that's it. They will learn the auto RP information. Okay. Another example of the example on how to configure the auto RP. Okay. In this case, what we are saying is this is the case for our RP sending the announce. I mean, the first line is saying I will send an announce over my loopback 0 with a TTL of 16 for the group 7, which meaning those are the groups that I want to become the RP, okay? And then the RP, well, the auto RP entity will send the discovery announcing that received announce, okay? Saying that from the loopback 1 for the scope of 16, which is the TTL also, again, okay? So it's the way that the auto RP works that I described before. Now we have Anycast RP and Phantom RP for PIM-BDIR. In this case, an Anycast RP is, as I mentioned, you can define several RPs with the same IP address and then exchange information with MSDP. This is a good practice because you can have a redundancy for the RP. If one of the devices reloads itself, well, in that way, that will force the traffic over the RP traffic or the control over the secondary device. This is a way to have redundancy for the RP. And we have the phantom RP for PIN bidir. PIN bidirectional, it's not really needing an RP, okay? So we can define an RP, but because the PBD will flow from the source to the receiver, well, you can define the RP, but the RP is not really existing, okay? And also we can set very good timers for the MSDP. As I mentioned before, well, please be careful with the timers. Every time that we change timers in order to keep an adjacency, we could impact the CPU. The problems for the intermittent sources. This is very interesting. There are some cases where the sources are sending traffic and then they stop, okay? And if they stop for more than 3.5 minutes, okay, this will cause that the PIN protocol will flush the states, okay? So every time that you start sending traffic again, the process to building the states all over the network will start again. And then if you have several sources in the network at the same time doing the same, this could cause a CPU issue for the network, okay? So what we can do here, well, the recommendation is we can use PIN-BDIR for many applications, okay? And the optimizations are, well, to keeping the states created in the network and not flushing them, okay? So one of the methods is to send a burst of null packets, which are packets that are actually empty, but they are forcing the states to keep alive. As I mentioned, well, in this case, PIN-BDIR or many applications, it's for financial applications, and it's mentioned at the last line. We can have also periodic keep alive or heartbeats. This will keep the states lived, okay? And we can change the S, G timers in order to wait more than 3.5 minutes, okay? And we have our final question. What application does Multicast has? If you have questions, please remember that you can share that in the Q&A section, okay? Here you can see, well, this is the topology that I was using for the demonstration here. This is the topology where I get all the outputs that we saw, okay? So, well, we will start with some of the recommendations that we have. Let's say, well, here you can see, well, I have the interface 00 from the last hop router connected to my PIM router, okay? OIP interface brief. No. And, well, one of the first recommendations is to have an access list to define the PIM neighbors. In this case, it's not implemented, so we are going to do that. Standard 11. Permit 4, okay. Yeah, and we will define the same here. Then the instruction, here you can see, well, IP PIM, and what we will use is a PIM pairing filter. Okay, in this case, which one? Well, the 11 access list that I have defined. IP PIM. And let me flap the interface. Well, here we are debugging PIM, okay? Well, you can see that I also flapped EIRP. Well, you can see here that we have the adjacency form, okay? And it's working now. But what happens if I change the access list? It's now 10. Let's say that I have a typo, 5. Now let's flap the interface. You can see here that this neighbor is explicitly denied, okay, because it's not included into the access list. Oh. Now I have it included it here. PIM says that the access list change, okay. So we have the adjacency again. Okay, this is the first one. Now, find a multicast range, okay? IP multicast group range. In this case, I will use this particular, which is allowing the auto RP traffic, but also the group 239.1.2.3. So I will send traffic from here. And oh, I'm sorry, not from here, from here. Show run interface E00. Okay, in this case, you can see that I have joined to two groups. Okay. IPM routes. But because I have defined a range for the groups that we can add, which is including only the 1, 2, 3, this is not happening, right? Oh. Shut. No shut. We will flap this in order to force the and all beam. Let me flap it again. It's not flapping on this way, in this side. I'm sorry. But well, this is protecting us from multicast, from unwanted groups. Okay, so in this way, if we send a join for a multicast group that is not included in this group range, it will be rejected. Okay, so IPM route, so it's not being installed. At this point for the lab, well, this is the only one that is allowed. Okay, so we will go for another one here. Now, I think that I have confused here. Okay, I will define another one. In this case, we will define a boundary, for example. IP multicast boundary. Oh, did I create the access list? Oh, IP access list should be the 11. Yes. No, but it's not. We will deny out. Mm, 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 mm. Okay, we are setting a boundary. Oh, I'm sorry, boundary out. So in this way, we won't send traffic for the auto RP over the interface that is going outside the network. In this case, this interface is the one that is connected to the receiver, okay, and the layer 2 switch. So there's no interest in having that. And well, we will define boundary. We have several options here. As I mentioned, well, we can prevent that interface from going to an state, okay? Let's say that we want to receive only traffic for some particular group. In this case, I'm going to use the access list for, because it's allowing only the group that we are interested. Okay, so I'm going to send traffic for an unauthorized group. Here you can see that I'm receiving the traffic. Well, I have also a message from a device wanted to be an RP. Okay, because I received that. To show IP. IP route. Well, we create this particular state, okay, but the outgoing interface is going to null. And this is because when I send this traffic that is excluded from the boundary, okay, it will stop the traffic here, so it won't go any further. Okay, now let's go to the RP. Okay, I'm going to create an access list. Uh, mm, Permit, then my authorized source. Oh, permit, I'm sorry. Permit IP host for the host. Okay, and then IP PIM accept registers. In this case, what I'm doing is saying that I'm going to accept registers only from this particular source, okay? So accept registers list 120, that's the source that I just defined, and this is the source. Show IP interface brief. Here you can see this is the source that I have authorized, okay? I'm going to send traffic. Here you can see that because of that, I sent the traffic. I have, in this case, this particular source, defined with an RP, which is this device, okay? This information is sent to all the other devices using RP mappings to show IPM route. Now let me run a debug to debug IP pin. Let me do this continuously. We are sending the traffic here. You can see, there's a register stop here because there's no, it's being accepted, I'm sorry. And it should flow, but it's not. In this case, it's 39.1.3. Okay, incoming interface is going here, but in this case, it's to null. Show IPM route. We are not forming that. Show IPPMRP. RP1, RP mapping. We have the mapping here, which is correct, but then I don't have the register. Why? Show IP PIM interface, which is correct. We have the neighbors. Prune message. Okay, that's correct because I'm not sending it. PIM mappings. Here I have, we are now troubleshooting the network. I have the RP information and everywhere, but for some reason I'm not forwarding the state. Show IPM route. Ethernet 01, which is correct. We are in this router that it says PIM, okay? It's the one in the middle, receiving the traffic from the first hop router, which is correct, and we should be forwarding over the 00, which is the one connected to the last hop router, but not here. Is this hop? Show run interface 00, yes. Okay, let's force this one. Terminal. Brief 01 IPIEMP. I'm going to place a static join here because sometimes in the virtual devices the layer 2 doesn't work that well. Okay. Show IPM route 39.1.3. I have this entry, which is correct. What does it say here? To show IPM route 39.3. I have the source, which is correct, but the outgoing interface is no, because there's no one here. Brun, I'm in Brun state. It's like this one is not sending the traffic there. Join RP not set across the RP boundary. Okay, show run interface E00, E01. Let's remove those boundaries. Interface E01. No. Apparently I had an error here. Okay, it was because of the boundary size. Set something wrong. So the boundary was preventing the state, the star comma G going to the RP. But now we have here, well, we have the register here for the group, okay? So the group that I define is from this source for this destination. So you can see here that, well, there are several ways in order to filter and to protect the network. So, well, that's a lot. And my recommendation here is, well, you have several mechanisms in order to protect the network. Please experiment with them. I don't know, do labs. It's easier now to have virtual devices and test the commands and see what they do before implementing in a production network. And please consider always the security, because in most networks where any protocol is implemented without security controls, sometimes we don't need an attack to have an issue. It's only to have something not forgotten, and then we implement something else and we break the network. So, well, the recommendation is always to have a very good routing design, and, well, especially for multicast. Well, that's it, Hilda.
Thank you very much, Luis, for sharing us everything here and for the demo. Thank you for all the audience who is just right here. At this moment, what I'm going to do is I'm going to share some of the questions that you have been asking. You also can make more questions here in the Q&A panel. So the first one is going to be for Miguel, who has been helping us to answer many questions in the Q&A. And this is like this, Miguel, what issues are introduced with using BCC or BPS in the core?
Hi everyone. Yeah, so basically on BSS, I have not seen any design consideration that you must have. However, for BPC implementations, I've seen many. Normally, the BPC for multicast is only supported when you have the BPC towards layer 2 path where the receivers are connected. That is for the access, because doing a PIM neighborship through BPC, while the PIM neighbor can come up, it is not a supported design. I don't know if I can draw something here.
Yes, of course you can share. Just give me a moment. I'm gonna give you the permission so you can share what you would like to share. So for those of you who are not here and you cannot join us, all the information, all the questions, and everything that has been presented here will be in the community in the next few days, including the recording and the presentation. So please go ahead.
I'm drawing here an example. We have two Nexus 7Ks running as BPC towards the Nexus 5K. Nexus 7K. And 5K2. So we have, if the receivers are connected to the Nexus 5K and the connectivity towards the Nexus 7K is via VPC, this is a supported design, but N5K, all this needs to be layer 2. However, if we have a connectivity upstream towards another router where we are running PIM neighbors, VPC is not supported there, and I explain you why right now. So basically, imagine that we are receiving the traffic from this router of here on the topology. Well, first, N5K has the receivers connected here. They do a join towards their gateway, which is right now on the 7K. When the N5K tries to send that packet, he's going to do a hashing and just choose one of the two. This will, imagine this will get to N7K2. From this N7K2 will do an IGMP synchronization to N7K1 using CFS, so that N7K1 is aware that there is a receiver on the VPC connected toward N5K. When the router starts receiving also multicast, he's going to do a register. Well, imagine the router is also the RP, and N7K2 needs to join towards that group to the router, because this guy is the RP. When this happens, the router is going to send out the multicast traffic towards N7K2, depending on the hash as well, because this is we're seeing the N7K2s as just a single logical device. When N7K2 receives it should send it out towards the VPC. However, we all know that on the last sub router, the one that the device that it actually does the forwarding for multicast is the designated router, the DR. On N7K2, even if you have configured the priority for one of them to be the DR, this will be overwritten based on who is the active VPC device for this. So imagine we have a failure here on N5K2. This one goes away, and N7K1 is the active or the DR for the VLAN where the receivers are active. Sorry for that. Well, so imagine that the RP router sends a multicast traffic to N7K2. This multicast traffic would then be sent out towards N5K through the VPC peer link between the N7K2s, the N7Ks. When this traffic, the scenario is packet arrives on N7K1, sorry, and imagine that N7K2 is the forwarding, the active, not N7K1. So when N7K1 tries to send out the packet towards N7K2, he will do it through the peer link, and when via layer 2, now N7K1, 7K2, who is now the active, wants to send out this packet since he's the DR, but to do it, he needs to do it via the peer link again towards N5K. So this packet would need to traverse the peer link again. Once it reaches N7K1, he will drop it because he sent out that packet through the peer link before. So this issue is removed by not doing VPC towards RP router, where these two links that are here are not VPC and are layer 3. That would mean that when the IGMP join from the sources gets to N7K, they will synchronize, and both would do a join towards the RP router, not only one of them. So when both do a join, the RP router would send out a packet to both of them, and one of them should have a link towards N5K, and that would be it. So, yeah.
Okay, thank you very much, Miguel, for such a clear explanation. Thank you, everyone, for joining. Due to this time, we won't be able to make any more questions and solve them alive. However, we will be posting and resolving most of them at the Spark event. I will place the event link on the chat so that you will be able to find all the questions or make further questions that you want to do. I remember to you that we have different social media channels that you can find more information, news, activities, and further events We are available on Twitter. We are on Facebook. We're on Google+. We're on the app if you're a customer or a partner. We're on LinkedIn, and we are on YouTube. There you can find more information. Also, we keep expanding ourselves, and we are available in different languages. So if you speak Chinese, Japanese, Russian, Spanish, or Portuguese, you can find more events in that local languages, or you can find information, documents, or even solve all your queries. If you're looking for more IT training videos or more technical seminars, then you can find most information about the Cisco Learning Network. They provide more webinars like this and others. So I will place this information in the chat so you can have more access to this. Okay. And finally, just to close this out, I would like to remind you that for your participation today, you can have and redeem a 35% discount with Cisco Press. So you can use this code CSC. And thank you for attending this session, then you can redeem this 35% discount. So I will place this on the chat as well, so you can redeem that coupon as well. Well, once again, thank you very much for all of you joining. After this session, then a pop-up window will come out with a survey. Please help us to answer this survey so we know how we can do better, what kind of topics you would like to hear, and what kind of things you would like to see in the community. So please help us to answer to this survey so we can get better. What I would like to say is thank you very much, Luis. Thank you very much, Miguel, for this presentation. Thank you all for all the audience, and I hope we can see each other next time in the further and upcoming session. Thank you very much, and I wish you have a great day. Thank you, Luis and Miguel.
Thank you, everyone. Bye-bye.
Bye-bye. Have a great day.